we will be starting exactly at 3:55, guys. We'll begin momentarily. Hi, guys. So I hope I'm visible. So for a moment, if you could
Yes.
turn on your cameras, that would be fine as well. So yeah, let's just start. Okay, we have about 35 participants. All right. Yeah. So hi everyone. I hope you all are fine in your homes during these difficult times. So I am Sarosh Dendoti. I am the co-founder and president of Genesis Data Science and Machine Learning Club. So today we have organized a workshop for you guys, which is basically on convolutional neural networks, and we will be working on a project called as basically gender classification. Yeah, so we started this club like a month back, and we have a lot of activities planned for you guys, like monthly meetings, discussions, work projects, research projects, and etc. So we have a lot of exciting content. So I believe everyone has joined the member group. Uh, yeah, so kindly do not leave that group because all of the further notifications of a club regarding workshops, discussion panels, research projects, they will come on that group. All right. So yeah, we basically focus everything on data science and machine learning. Occasionally, we'll also take workshops or small meetings on pure coding practices as well, such as algorithms and data structures. All right. So, and at the end of the month, we have also planned newsletters like what we did, and if you guys have some amazing projects to show off, we will also provide you the platform to basically show off your projects on our YouTube channel, or in our newsletter magazine. All right. So yeah, I believe we have 42 participants, and the time is 4:36. So I believe we can get started now. Uh, I hope so. You guys have downloaded the Drive resources, which were provided to you on the members group. Yeah. So I believe we can get started now. Sanya, you can take over from now. You can get started. And
Yes.
a slight request, please keep your microphones off. If you have any doubts, you can just put them in the chat box. Our team members will be glad to answer any of your questions regarding the workshop. All right. Yeah, I pass over to you, Sanya, now.
Thank you so much, Sarosh. So, guys, welcome everyone. I hope you have downloaded the resources I have shared in the Drive link. Can I get a quick yes in the chat box if you have downloaded everything? Okay, most of them have done it. So, let's get started. Is my screen visible to everyone?
Yes, yes.
Okay. So just search in your Google Chrome, Google Colab, and then click on the very first link. I hope you all are following along. Now we'll be uploading our notebook, the guided notebook which we had shared in the Drive link. So just choose the file here and choose the location wherever you have downloaded that link, or wherever you have downloaded that iPy notebook, and open it. So I hope everyone has opened the notebook. Well, let me show you around Google Colab. So here from edit and notebook settings, we can choose our runtime settings. Like if you want to run this notebook on GPU or the TPU provided or none. So only if you want to use GPU, you can select GPU. I'm gonna save it here. Now in the left panel here, we have the contents. So as you can see, the guided notebook provided to you has all the contents listed. So step 1 to till step 6 and till the end. Here you can see your contents, and here we have files. So files is basically just like, just a minute. So here we have our files. You can upload your files from the PC itself, and so you can use it in our notebook. So we'll be using this a lot. Okay, now welcome everyone. Since our guided project is gender classification using convolutional neural networks, I'll be first introducing you to what actually a CNN or a convolutional neural network is. So as you can see in this image, a convolutional neural network, it is a network which comprises of mainly two layers or blocks, you can say. We have the first block called base and the second block called head. Now this convolutional neural network is usually used to classify unstructured data like images, videos and all. So in this image, there is a car. So what kind of features our neural network will extract? Maybe the car color, the wheels on the car, the lights, etc. So all these features are extracted on the base level. And then according to these features that are extracted, we will have the head, which will classify the images. Now, what do you think, what kind of car this is? Anyone knows here? Well, it is a Volkswagen Beetle. So it has classified into VW bug here, as you can see, the output. Now the feature extraction process in this base, it comprises of three basic operations. So we have first filtering, then detection, and then condensing. We'll go through these features one by one. So first is filtering. So filtering an image for particular feature. This will be done in a convolutional layer. So let's see what a convolutional layer is. So the weights, each layer has weights, so which are also known as kernels. They act as a lens. As you can see in this image, the kernel is acting as a lens over the input, and there is the output layer. So basically, the kernel is an array. It can be any shape array like 2 by 2 or 3 by 3 or a 5 by 5 array. So here we have a 3 by 3 dimension array. Now it can de-emphasize or emphasize the features from the input. As you can see here, the pixels on the input image are scanned, and the weighted sum of this pixel values is there in the output. So there are various kinds of kernels we can use depending on our need. So as you can see here, this is a 2 by 2 kernel. This is a 3 by 3 kernel. Now what these values signify is the negative values are mostly unimportant features that are extracted from the image. And the positive values are the important features. The more positive a value is, the more important that feature is. Now different kernels produce different features. You'll learn to code this soon enough. Well, next we have rectified linear unit or ReLU. So it does a detection process. So what the detection process is, as you can see in this graph here, all the values which are in the negative side or all the values which are less than 0, rectifier function deems it unimportant, equally unimportant. And all the values which are greater than 0, they are all important. So basically, if you see difference between this image and this image, you can see that all the negative features or all the unimportant features are blackened now. Well, so this is the main function of a rectifier function. So all the negative values are not important, so it sets them to 0. And all these features that are obtained, these are called feature maps. Now, why is this called a rectified linear unit? So a neural network is made of a very large number of neurons. So each neuron, when we apply a rectifier to a neuron, it is called a rectified linear unit. Now next we have the condensing process. So
excuse me, Sania.
Yeah.
Can you please go a little slower?
Okay.
Yeah.
I'm sorry.
Yeah. No problem.
Well, I hope you have understood the detection process and the convolutional process. Everyone? Okay.
Yeah.
Okay, thanks. Next we have maximum pooling layer. It is also one of the layers inside our convolutional neural network. So basically it condenses the features extracted from ReLU. You can see in this image very easily, like this is the original image, and after applying max pooling layer to this image, the feature, you can see a lot of dead space here, lot of zeros in here. So what maximum pooling does is it condenses this feature map to retain only the most useful part, that is the features itself. So when we applied the ReLU function on our filtered feature map, so it had the effect of intensifying the features. As you can see the difference between this and this, the features are more intensified. So pooling step just increases the proportion of this active pixels than the 0 pixels. I hope everyone gets this. So summing up of all the above concepts, so this was our input image, and when we apply convolution layer, so that image is filtered. A filter is applied to that image, and then when we apply a rectified linear unit function on this feature map, it detects the features, and when we apply the max pooling layer, it condenses the features, that is it emphasizes the features a lot. So these three steps constitute one block in a convolutional neural networks, and if we keep on repeating these blocks over and over again, we get a handful of features which we can train on. So more deeper the neural network is, that is more blocks we have, the superior will be our neural network. Now, next, the most important part of a project is the data set. So let's start by importing our data set itself. So step 1 is importing the data set. I want you to run these cells without any changes. Now there is a shortcut to run the cells. You can use Shift plus Enter or Control plus Enter, or you can just press this button here. So it will be connecting to the GPU, TPU, or your CPU itself. And when the cell is completely run, it will show a green tick mark here. Now this will clear our output. If I press this, it will just clear the output. Now we will make a directory called .kaggle using this mkdir command. Now I'll just control plus enter. Okay. Now please follow these next steps. I'll show you. Now go to kaggle.com. I hope everyone has made their own Kaggle accounts. Now here on the top right, press on your profile and click on the account settings button. Yeah, and under here, under the API section, please press on create new API token. Now this will download a JSON file. So just remember where you are downloading it. After you download the kaggle.json file, you go back here and here in the files section, press on this button here, the leftmost button, upload to session storage. Okay, now I'm gonna just import my kaggle.json file and then open. So it gives me a dialog box that uploaded files will get deleted when this runtime is recycled. So if you refresh the runtime, these files will be deleted and you will have to import them again. Now, next, after downloading this JSON file, I hope everyone has downloaded the JSON file and uploaded it in here. Okay, after doing this, after loading the JSON file into the files section, we will just copy this JSON file into our .kaggle directory. So this is the command for that. I'll just control plus enter. And then you don't need to go in depth of this command. It will just provide some essential permissions to the JSON file. Run that, and then since we are doing a gender classification project, we will now download the classification dataset. You don't have to make any changes in your notebook, just run these files. So it will show that 100% downloaded. Is everyone getting the same output? And after that, a zip file will be downloaded. As you can see here, downloading gender classification dataset.zip. We'll just use unzip command and the file name. Now I'm gonna unzip this. So it's gonna unzip all the images in the dataset. You can see there are male and female classes and .jpg files. Yeah, so we have been notified that the cell has run. Okay, so this was it. I hope everyone has imported their data sets and everyone understood how to run around this Google Colab. Is there any doubts in these parts? Or is there any doubt in the explanation part of the neural network? This guided notebook will be with you, so you can always refer these images and description. Now I'll be requesting Aniket to please take the further part. So we will have the next steps, importing the libraries, image data generations, and seeing or plotting our images, and finally building our convolutional network. So Aniket Wagh, which is the technical head of Genesis Club, he will be taking the further part. Yes,
okay.
Aniket.
Hello guys, good afternoon. So let me just share my screen. Yeah. Can you please give us a definition of neural network? chats here. Can you please? Hello. Just a second, guys.
So Prathamesh has asked a question. Can you give a simple definition of a neural network? So you can take your own example. So if you want to study something, like when you were a kid, you wanted to learn how to cycle. So you practiced it again and again until you got perfect in that. So neural network does the same. So it will train on a specific data again and again until it learns that data. So that you can perform various prediction and detect frauds even. I hope you got it, Prathamesh.
Guys, so is the screen visible? Is this visible, guys? Okay. So let's start. Let's start with importing the libraries. As Sanya have explained you about basic convolutional neural network and stuff. Let's start with the hands-on coding of the section that we have just learned. The libraries. That we have already.
Excuse me, Aniket.
Yes.
Your voice is not clear.
Just give
Until then, guys, I'll share you the drive link again if you have not downloaded the notebook. And if you want the recorded version of this meeting, the meeting is right now live streamed on YouTube. So you can watch it anytime. If you have any doubts in importing the data set, you can just go there and watch it again.
Hello guys, sorry for the inconvenience.
Aniket,
So,
now you're
is my screen visible now?
audible. Yeah, you're audible now.
Okay, so is my screen visible now?
Yes,
Hello?
yes, it is visible now.
Okay, okay, so sorry for the inconvenience. Let's start with importing the libraries. So guys, we'll be using TensorFlow Keras for our pre-processing and model building. But we'll also need libraries such as NumPy and Pandas to handle the data that we'll be having. Then we'll have libraries such as Seaborn and Matplotlib for plotting our plots that we'll be getting as accuracy plot and our validation accuracy and losses. After that, mainly as I mentioned, we'll be using TensorFlow, and from TensorFlow we'll be using Keras API. Further along the tutorial, I'll be explaining the importance of all these libraries that I have imported over here. Let's start with the main step of our data preprocessing, that is data generation. So what does data generation does is data generation generating batches of tensor images data with real-time data augmentation. Example, rising all the images, adjusting their heights, widths, so that the input image data is uniform. Like in real world conditions, we do not have a uniform or standardized form of data, like same image, we don't have it. So we need to pre-process the data set so that we can get the standardized form of batches all along our data set. So for that, we use some function called as imgen, in which we have arguments such as, let's say, rescale, then share range, zoom range, then shift the height, then shift the weight, and fill mode. So what we'll be doing is taking a look at each of these argument one by one and then coding it ourselves. So follow along. So let's start with our share range. So what share range does is share range uh, changes the angle of the image and saves it so that we can have augmentation of that image. Share range basically deals with the angle of the image. Then we have the zoom range. Zoom range, as the name suggests, zooms out the image and try random zooms on the image. And then there is height shift and width shift, where we can use it for manipulating the height and width of the image. And then we have fill mode. Let's say we have our image, one image is there which is very small and we want to make it large. So by using our fill mode, we use our argument fill mode to expand the image. We use, in this case, we'll be using the nearest the default setting, which will just replicate the nearest pixel and fill out the image to our desired image dimensions. Then we have our validation split. Validation split will basically split the data into training and validation section. And then moving further, let's code this. Yes.
Your voice
Yes,
is
Sanya.
cracking in between, so please go slow.
Okay. So let's code these functions that we have over here. You guys can follow along. As I code, you can code the same functions that we are going to be using. And if there is any doubt, you can put the doubt in the chat. Let's start with the very first function that we'll be using, that is rescale. We'll set the rescale as 1 by 255. So why do we choose this number? Why do we choose this number? We choose this number because there are total 255 values of every pixel that we are having in our data set. So that we need to normalize the data set. That's why we're dividing it by 255 every pixel. And after that, we'll be setting the share range. So what share range deals with is the angle of the image. So let's set it to, let's say, 0.2, and then it's sharing, sorry for the typo. And then the next function that we'll be manipulating will be the zoom range. So zoom range is basically set a zoom, constant zoom for every image that we'll be having. Then we have the width shift. Range, and for that we'll be using 0.2 only. So basically this is just for prototyping purpose. So by this you can, in real world conditions where you have real world data, you will have to tweak these arguments according to whatever fits you best. These are also called as hyperparameters, by the way, which you have to tune according to the data and the model that you will be training. So let's set this to as 0.2, and then select the fill mode. As I have explained what fill mode does to the rest. So I hope you guys are following along.
Yes,
yeah, you can post in our chat section that if you have any doubt. Okay, so keep in mind the Python is indentation sensitive. So if you just miss out some spaces or tabs over here, you will run in an error. Okay, so basically same. What we'll be doing is using the same rescale for our test gen as well. So let's give this argument over here. So use the scale function, and then set the rescale to, and then run this cell. So as you can see, I have successfully run this cell. So let me know if anyone of you are having any problem, if any error is popping up. So you all can just turn on your microphone or say yes or no if there is any problem or not, or just type in the chat section if you all are following along. Hello?
Yes.
Okay. So let's, as we already have our objects as testgen and traingen, we'll use the dataset that we have in our directory that we have downloaded. As you may have followed what Sanya asked you to download, like the gender classification dataset that we have in our file systems. So what we'll do is we'll take the path of the directory and generate batches of augmented data. So the arguments that we are going to deal here with are target size, seed, batch size, subset, and shuffle. So one by one we'll see what this will do. So target size is the tuple of integers, height and width, default to 256, 256. The dimension to which all image found will be resized. So all the images in our dataset will be resized to 256. In our case, it will be another number. So it will be in the sequence like this will be the height and this will be the width. Coming to the second argument, that is SID. So it's an it's an optional argument, but to have consistent results on every device that we run this code on, we have to set a SID. So for that, SID is basically an optional random seed for shuffling and transformations. And then we have batch size. Batch size is the size of image data that you will be passing in a model at one instance of time. So here we have the default batch size is 32. In our case, we'll be setting the batch size to a different number as we follow along the tutorial. So then we have subset. So like in every object that we create from the above function, we'll have to define like what subset it actually belongs to. Like, is it a training or a validation set? So depending on this argument, it will be our model will get that this is the training set. So we'll be using this as training data and for validation as well. So for the shuffle argument, if we set this argument to true, which is like default true, so the data will be shuffled in a random way using the seed variable that we have set already. And if it's false, then it will be sorted in an alphanumeric order. Okay. So coming to the code part, let's import the data that we have in our directory, like in the training and the validation set. So let's start. I want you guys to just follow along and code with me these functions. Okay. So let's set the target size. Target size for the reshape that we have to do as 96 by 96. So we'll be having height of 96 and width of 96 of every image that we have in our data set. Then the seed that we will choose any random number. It's on us, whatever we want to choose. But in this case, for consistent results, let's choose 1, 2, 3. We'll have this seed set as 1, 2, 3. Then the batch size. So basically, as I have explained, batch size is the number of images fed to a model at one instance of time. So batch size, let's keep batch size as 16. Okay. Batch size, as I have not defined the variable above, let's hard code it to 16 only. And then let's move ahead and do this subset as training. Do not forget the double quotes. So yeah. So similarly, we have to follow this same argument pattern for validation set as well. So I'll just copy this and paste it over here. Cut the subset, the one which says training in it, and then everything else will be same. So it's no problem. Just keep in mind there is no indentation difference in any of your arguments. You don't run into any problem. Okay, so yeah, I think I have solved it. Yeah. So similarly, we'll have the same arguments in our SDS as well. So let's paste it over here and take care of the integration that we have to follow. And yeah, just run it. Yeah, so now you can see that in output section we have found like near about 39,959 images which are belonging to two classes, out of which we are using 7,050 images for our validation set and 11,649 for our testing set. Okay, so moving along, we have so let's check what classes do we have in this data set. Okay, so we have, as mentioned here, we have two classes. So what classes are they? By running this cell of our notebook, you will get that there are two classes which are female and male class. So let's augment the data. Okay, let's see the augmentation that we have applied over here in this, the rescale, the share range, the zoom range, the width, and all. How is it affecting our images? Let's check it out. So first, I want you all to just run the cell which says, let's see our augmented data images, step 4. After that, let's call this plot image function. Okay, so for that, all I have to do is write the function name and just pass the x and y in it. Okay, after that, you will see we'll have a grid which will display the faces with the labels of the image. Like this is a male image and this is a female. You can see consistently that the fill mode that we have used, the nearest pixel replication, it has been replicated all along the image dataset. Like you can see here the elongation of the pixels, like here and here. So in some images it was not necessary as the image was big enough, but for maximum of the images the fill mode has worked. So yeah, let's now build a convnet. So basically, as Sanya explained, what convnet is, we'll be using the same concept, but we'll be implementing it using the Keras library, which is provided by TensorFlow. By the way, TensorFlow is a Google's product. So I just wanted that. I wanted to tell you. So let's start with the convolutional block. So a single round of feature extraction can only extract relatively simple features from an image. So things like simple lines or contrasters. Yes, Sanya.
Can you go a bit more slower?
Okay. So I think you guys are following along. So let's discuss convolution layers more. Like how convolution perform feature extraction through 3 operations like filter, detection, and condense. You have seen before. Sanya has explained you that. Like we have a filter size, and it reads the it pans over the image that we have, and please repeat the command of showing image. Okay, yeah, sure, Pratik Thomre. So you just have to put in this. You have to call the function that we have already defined for you, like the plot images function, and then you have to call the function and pass in the argument as x and y. Is it clear, Pratik? I hope so it's clear. So let's move forward. So discussing convnet. So what convnet does is a single round of feature extraction can only extract relatively simple features from an image. Things like simple lines or contrasts. these are too simple to solve most classification problems, as most classification problems that will be finding in real world conditions may be way more complex than just classifying genders, like is this a male or female. So instead, convnets will repeat this extraction over and over so that this feature became more complex and refined as they travel deeper into the network. So like let's consider this is a convolutional block that we have in our neural network. So as we go deeper and deeper, that means as we have more of these convolutional blocks, we'll extract much much complex features out of this image. So this convolutional block, let's say in our neural network, may only see the lines and horizontal lines and vertical lines in our image. Then the second one may only detect shapes like squares and circle, basic shapes. Then the third one may only detect the like the faces and other objects lying around in our image. So basically, as we move deeper in our convolution layer, the feature extraction that we have will increase. The complexity of the feature extraction will increase, and we'll have better understanding. The network will have better understanding of the image that we have passed into. So how a convolution, what a convolutional block consists of is a convolutional layer, a Con2D layer, in which we pass in the input. Then we have a ReLU function, and then we pass the output from the ReLU function in a pooling layer. So after that, we get our output. So now let's define our model using Keras. Okay, so let's come to the block of our model. Then as you can see, we already have some code over here which says that image input equals to input, and then the shape is given. So basically what we are doing is telling our model like what shape of data we'll be using. Like in our case, as we have reshaped the data already to 96 by 96, that is 96 is the height and 96 is the weight. And the type of images that we'll be using are mostly JPG images, which only have 3 color channels. So we have this third dimension saying 3 over here in our shape function. Coming to the next line, which is the first block of convolutional layer that we have in our model. So here you can see that the first layer is a Con2D layer. In this layer, the first argument is nothing but the the number of Con2D units that we are going to use in our neural network. So we'll be using, in this case, we'll be using 32 units of Con2D. You can adjust this according to your convenience, according to your data, based on what data you want to run this model on. What features exactly are you looking for? After that, coming to the second argument, which is in a bracket, it seems like a coordinate, but it's also a dimension of the kernel which Sanya mentioned above, which extracts the feature from our image. So this kernel or filter, we may say it filter as well, is 3 by 3. So we have like 3 as height and 3 as width of the filter. So after that, it's also it's a 3 by 3 array as explained above. So the activation that we'll be using is ReLU activation, and after that we'll be passing this image input into our Con2D layer. After it, we'll be applying batch normalization on the output that we get from the Con2D. So the batch normalization, what batch normalization exactly is, as I have mentioned above, images into our neural network. So the batch of images must be consistent all throughout. Like we can't have different kind of some images may be bigger and some may be smaller in size, and size in megabytes or KBs, or size in such as height and width. So basically batch normalization will take care of it, and after that we'll be applying the max_pool2D layer, which will further compress our image. In this case, it will make our image, it will compress our image into it's half size. After that, you may see this dropout layer. So I'll come to this dropout layer once we start our training. So keep that in mind. This dropout layer is very important, guys. I'll come to it once we start the training of our model. So this is only the first block of our model. Let's code the second one. Okay. So you can follow along with me and code the second block of our model. So let's start. Like we'll be having the conv 2D layer. So we'll be having conv 2D layer, and by now we'll have 64 units of convolutional. We will have 64 convolutional units, and then a filter size of 3 by 3 will work, the similar as above, and the same activation function we are going to use, that is ReLU. And for this layer, the input will be the previous layer's output. Like the dropouts output will go as input in the second layer, and after that, as above, we'll have the batch normalization layer over here as well, as the image is modified a bit in the batch pooling layer. So we'll do that again. Okay, so batch normalization. After that, the batch normalization, the input for the batch normalization layer will be the output of the conv2D layer, the above layer. After that, similarly, we'll have a max pooling layer. For better extraction of features in our next layer, we'll give it 2x2 filter only and pass the previous layer's output into this as input. After that, we'll have a dropout again. So I'll just give basic idea of what dropout does. Like we have like 50,000 images of female and male faces in our data set. So our model may think that male and female, whatever it learns from the data set, the male and female images are only, it may think that whatever images are included in these two folders are only those images are only male and female. So this is called overfitting. Like the model won't run on generalized on real world data. So for that we use dropout. I'll show the use case also of dropout once we move to training. So this was just a basic intuition of what dropout does. Then we have third block, which is similar to the second block. So we'll just copy the second block and go here. Just change the number of conv units that we have, convolutional units that we have. In this case, we'll use 128. And after that, in the third block, as we are done with the third layer, we also have a fourth layer. So before that, we have applied this flatten function. So basically, whatever output that we will get after this dropout layer, it will be in some kind of, it will not be in single dimension. It will not be in single dimension. We may get a multi-dimensional output with basically, as we have passed in a 3-dimensional image, we'll get a multi-dimensional output over here. So to pass that output to our neurons, which are dense neurons, connected neurons, we need to flatten it out. So like convert it into 1D array. After that, we'll pass it into a dense layer. So dense layer basically is the learning block of our neural network. So basically all these 3 layers, what will this be doing is they will be extracting the features, and according to whatever extraction they will be doing, this dense layer will learn from those features. So let's code our dense layer over here. So dense, and here also we have to give the number of units the dense layer will be having. So in this case, we'll use 256 units. And then the activation, we have to give the activation, whatever we'll be using. In this case, we'll use ReLU. And then we have to use the batch normalization for normalizing all the data points in our batch. And then after that, we'll use dropout here as well, so that our model does not overfit on the data. Come on, so guys, depending on the nature of the data, we use dropout. Like in this case, we have 50,000 images of both male and female classes. So it's pretty much necessary for us to use dropout often here, so that the image the model does not overfit on our data. So in this case, the dropout value will choose a little bit higher, that is 0.5 in this case. So let's pass in the input from the previous layer here. Yeah. So we are done with the fourth block of our neural network, and then so the image output, the output layer, that is. So the output that we'll be getting is we'll be getting two numbers, two float numbers, which will tell us the probability of both the classes. That if it is a male, then how much percent the model think this person is a male, and how much confident the model is about if this person a male or a female. So that for that we'll be using 2 units of dense layer over here, and activation function, activation of softmax. So softmax, and output from the previous dropout layer will be added into this. Then we make an object out of the model class that we have, and just run this cell. Let's hope that we do not encounter any errors over here. So we have some errors. Let's find out what those are. So it's in the 28th line. So yeah.
Hey Aniket.
In the fourth block, I guess. Yes.
No. You didn't fill in the
I have not
of the model class on the last line.
Yes. So sorry guys, I forgot to give the image input and image output dimensions over here. Okay. So after this, let's try rerunning our model, and now we have no errors. We have also forgot to pass in the flattened layers input over here, so just include it over here and run your cells. If you have any problem, just post it in your chat section. Are you guys following along? I hope so. So let's move ahead to model summary, like what all layers do we have in our model, and what all parameters does it consist of, and how many parameters in total are we going to train in this model. Let's check it out using this model.summary function. So let's run it, and here is a little summary of our model. So as you can see, we have layers, the number of layers and the type of layers that we have in our model, the output shape of each layer, how the output, like the shape of our image is being manipulated in each layer, and then we have the parameters, the number of parameters being trained on each layer. So as you can see, as we move down our network, the image is getting smaller and smaller, and the number of filters is increasing. Like in the first case, it was 3, then 32, then 64, and then 128. And then after flattening, after applying the flatten function, we just dissolve these dimensions and make it into one dimension only. So after that, and the last layer consists of our output layer, so it has only 2 units. So it will give the probability of if the image is male or female. So coming to the training the model. So this is one of the the easiest, but the most important part of our model building, of our deep learning. Here, what we'll do first is we'll compile the model, set an optimizer, a loss function, and a matrix to follow. And after that, we'll set up something called as my calls. So let's first code out this model.compile function. In this model.compile function, we'll use optimizer, Adam optimizer, and the loss that we are going to use is categorical cross entropy, as we are dealing here with categories. And then the accuracy will be accuracy matrix. So let's type in the optimizer over here. So the name of the optimizer is Adam. The loss that we are going to use is category loss entropy. Okay. So I hope I haven't made any typo here. Let's fill in the accuracy. So let's run this cell. So it's successful. We have compiled the model successfully. Now coming to my calls. So basically, whenever we run the model, train the model, we don't know how many number of epochs we'll be going to need, like how many number of iterations the model need to go on the data to learn from it. So for that, we'll have to set a value for epochs, but we don't know what epoch size should we use. Like we can use any random number, but it won't make sense. So for that, we'll use this my calls. Here, if the validation accuracy, I'll explain you what validation accuracy is in a minute. It's basically accuracy of the model in real world conditions. So it will monitor the validation accuracy. It will see if it does not change in 3 iterations. If it does not change in 3 iterations, it will save the model as model.h5 in our directory and end the model training before it hits the epoch number that we provided here. So let's start. Let's run this cell as it has already been provided in the notebook. After that, let's train the model for a fixed number of epochs. And yeah, so you can code along me. The train DS that we have defined above using the train gen function, and then the epochs, number of epochs that we are going to use. In this case, let's take 22. You can take whatever you want, just for having the same results as we are having over here. Use the same arguments. So select 22 epochs and then validation DS. So validation DS is the data we'll use for validation of the model, like how well the model can perform in real world conditions. Then for the callback section, we'll provide the my calls that we have defined over here. Basically, it will deal with the monitoring well accuracy and terminating the training if the model is not learning anything. So let's start training up the model. Let's start. Okay. So until our model trains, so first of all, you guys let me know that are you guys following along? Is there anything that you have missed on? Are there any errors you are facing? Hello? You can put the errors, whatever you are facing, in the chat box. Hello? Okay, so I guess there are no errors. You can still put your value error in fourth block. Okay, value error in fourth block. I'll check. So in fourth block, and what layer is it giving value error? Pratik.
You can turn on your mic and tell us, Pratik. Or you could just place your error.
You can speak up.
You can just speak out, guys. No need to.
Yeah, you can paste.
Move here.
Yeah, and you can also paste the error in the chat box so that we can analyze like what basically is going wrong. So as you can see, we have started training the model. It's the first epoch out of 22, and the estimated time is 1 minute and 27 seconds as of now. The loss that we have is 0.8, and the accuracy we have on our trained data is 0.67 as of now. Once the model is trained more epochs, the accuracy will increase. And once epoch is completed, we'll get a validation accuracy, which will basically the model predicting on the validation data that we have provided over here and calculating the accuracy. So yeah. Yeah, I guess it will take pretty much long time, as this whole operations will be run on a GPU, a multi-core GPU, which will handle all the calculations, all the forward propagation and backward propagation. And so
I
Sanya
think
is the yeah.
Sorry.
Sanya is the model that we have. Is it uploaded on the drive that we provided?
Yes, it is uploaded.
So
While the model
okay.
is training, we can also discuss if you have any doubts or anything. Okay, Pratik, your error is solved. That's good.
Okay, that's nice. Okay. Okay, guys. So I guess we have provided you with a model in the drive. So you just have to head to the drive that we have provided, that, and just download the model 1.h5 file, which is over there. Download the file. After that, after downloading the file, just drag the file from your local system and drop it in this file system that we are having over here. So in my case, I'll do it in just a second.
So basically, in your callback section, you are saving a model into a .h5 file. So unless your training doesn't stop, or until it continues, you will all the weights will be stored into the model.h5, and then you can use that file by loading it into your notebook and performing predictions on the basis of that model. So since it will take a lot of time to train, we have already trained a model for you, and it is present in the drive link which we had sent. So I have updated the drive link. So please check it out and download that model1.h5 file.
Okay, so until the model trains, we'll observe whatever values that we are getting in the the output section of the model.fit cell. So coming to the first epoch is already done. So we completed the epoch in 185 seconds. So that is 56 milliseconds per step. Then the loss that we have, the accuracy, the training loss, we have is 0.6371, which is a very good number, by the way, guys. And accuracy that we had on the training set is 72%. And the validation on the testing set is 0.3963, which is better number than this one is. So, and the validation accuracy is 82.61. So you may see the difference, that the accuracy that we are getting in this training set, the training set that we are using basically to train the model, is more than the validation accuracy that we are getting on the validation set. Validation set is basically the model is tested on. So it is because the dropout layers. If you remove all the dropout layers from our model, the model will perform better on the accuracy, which is the train accuracy, and the validation accuracy will be less than the training accuracy. So it can result in overfitting. So we apply dropout. That's why. After that, you may see that it is logging that validation loss improved from 0.3962 to, so it is saving the model. It is because of the mycall function. It is really helpful. So the model that I am trying to upload in the files is uploading. It will take some time. Until that, you guys can ask us any question that you have in our mind about whatever we are doing. So guys, anything you want to discuss about convolution layers, or anything you want to tell? Like, can you guys tell me where do we use this object detection and computer vision stuff? Where do you see it more often in your real life? Jyot? Yeah, phone face ID. Yeah, yeah. It's the right answer. Yeah, phone face ID. You can also say that the basic camera app that is there. Not a robot. Yeah, I'm not a robot. Not exactly, Rohan. That is a different part. That is altogether a different field. Like we don't use any artificial intelligence in that. I'm not a robot. It's basically uh, algorithm that senses if there is any Autobot that is doing all this signing up and signing in stuff on website. That's a different thing. The most basic
Yeah.
the most basic encounter that you may have in your life with computer vision or object detection is the basic camera app in your mobile. Sometimes in some mobile phones you may have observed it tells you like what age this person is, whoever is facing the camera and stuff. Or let's say in your Facebook tags. So now Facebook tags you automatically on any photo you're present on, which you upload on Facebook. So how does Facebook get to know that it's you? Like they all uses this algorithms like on a very much scaled manner. The models are way bigger, way complex, and the data is like real world. As we have only provided us our data to them, so they use the same data and do the predictions on it and tag us in our random photos. Yeah, so I guess the model is still in the uploading phase. Any question from your side?
Yeah, even I had seen the use case of this facial recognition in intelligent military-based systems.
Yeah, basically yes, that is also there. Uh, uh, we we use it more often, even in the you may have seen if you break any traffic rules nowadays. Basically, if there is any camera or something, most of them, I'm not saying all of them, most of the cameras are automated, so it will detect automatically if you are breaking any traffic rule, and then it will raise a ticket that is this a violation or not, and then a person will take it, like approve it or may not approve it depending on whatever the case over there is, and we'll get a challan if we are breaking the traffic rule. Would this be used in image refining? Yeah, in a way, yes. Like conv layers and convolution layers, we can use in image refining, like converting the image from more noisy images to more refined image. We can, but the process is way different.
Yeah, it is usually used to convert vintage pictures into more good resolution images. So Pratik has one more question.
Yeah.
How much time will I need to study and build a system for fault detection? For example, fault detection in Coca-Cola finished bottle. Faults like shape, excess, or less drink filled in the bottle. Label is not present on the. Okay, so basically for this you will need that kind of data. You will need to collect data of various Coca-Cola bottles and classify them into good and not good, and train this data in a neural network. Yeah, since these are images, convolutional neural network work best with unstructured data. So you can do it that way if you want.
Yeah. So Pratik, the most basic thing that you will need is the data itself. And coming to this time, the study time that you asked for, if you already know what machine learning is, like not deep learning, I'm talking about machine learning, what machine learning is, and you want to start deep learning, it will take near about, let's say, 2 to 3 months for you to build such kind of systems, like which can detect faulty and not faulty bottles. Yeah, so I guess we have successfully uploaded our model that is provided in the drive link. So I will stop the training here. I'll terminate it manually. It will throw out an error, a keyboard interrupt was there. As I have done it manually, I've stopped them manually. So let's move to the deployment of the model. Basically, what most of the people indulge in data science and machine learning, deep learning do is they collect the data, they pre-process it, they train a model on it, but then they don't have enough skills to deploy it. Like they can't use the models. They don't know how to use this object detection model in real world, like how to feed images into it from camera, or how to use saved images from a directory to test the model in real world conditions. So for that, we have deployment here. We'll use this deployment, deploying the model, the step 6. So I hope you guys have followed along till now and will follow along. So now we'll check how our model performs on custom images. We'll first pre-process the image we want to input in the model, like reshaping, converting it into array, then face detection and cropping the image. So basically, whatever the data that we had was the face data. So for that to be classified first, we first have to detect the faces from the image, like where the faces lie on the image. For that, we'll do basic face detection using a hard cascade method. I'll come to that in a little further part. Then we crop the image where the face area is, and then we use that image for our testing. Okay. So here are also a couple of libraries that we need to import. There is this PIL image library that basically deals with pre-processing and importing of images and stuff. Then we have IPython.display from which we are importing the display function, which deals with the displaying of images in this case. And then we have imported NumPy again. It was not necessary. I guess this was a mistake, but okay, let it be there. There is no harm in importing a library. Sure. Give us any error. So let's recreate the exact same model, indulge its weights and the optimizers. That is, load the model from our directory. Okay, so let's take this model 1.h5 that you may have downloaded from the drive link that we have provided. So let's go model 1. By the way, guys, this model was trained using the same exact technique that we shown above. Just the number of epochs were more, as we had a lot of time before this tutorial. So we trained it like for an hour, I guess, and then we exported the model. And then after the exportation of model, we can deploy it anywhere, wherever you want. It's in .h5 format. We can also export the model in many other formats. Like there is also this pickle format that we have. Then after we'll save this model in this new variable, that is new model, and let's see what this new model is consist of. It will have the similar layers and all those things that we had above, but let's check. So here TensorFlow is not defined. Okay, so we have not imported TensorFlow, so just correct this, import TensorFlow. Okay, and then run this again. Okay. Okay.
Spelling.
Oh shit! I just did a typo over there. Yeah. So okay.
I guess you should do import TensorFlow.
Yeah, it has successfully executed.
Cool.
So now it has successfully run, and now you can see the same number of reshaping is being carried out throughout the model. The same number of layers are there. Same type of layers are there. The trainable parameters and the non-trainable parameters are same. So exactly the same as we have before, the model that we have trained on. So let's take some examples over here. So as you can see, I'll first open a image. Let's see, this is an image of a girl. Okay, as you can see, as I can tell from the appearance, it's a girl. And once here we are using the library which is OpenCV to read the images from our directory and convert it into a certain form like an array and stuff, and then we'll pass using this hard cascade frontal face classifier. Will detect basically where the face lies on the image. Like I'll just pass in the name of the girl.jpg file. It's JPG. And now after that, I'll just detect if there are any faces present in this image that we have given above. If there are any faces, then we'll grayscale them, and we'll for each face present in the faces of the image, we'll do a prediction. Okay. So let's run this cell.
Guys, just a minute, Aniket.
Yeah,
For
I guess there's a data.
this, you need to install Har Cascade Frontal Face all2.xml file. So that file is mentioned in the drive link itself.
Yes, guys. I have also not downloaded it. So please download it, as I am also doing it. So
Aniket, I have the drive link in chat section. You can
download. Yeah. I've got it. Okay, so I'll just upload the Har Cascade Frontal Face XML file that we have, and yeah, it's uploaded now. Let's check out the detections of faces that we have in the image. .jpg. So yeah, it's in an array format. You can't see it right now. There is a bit of a disadvantage of this Google Colab platform. We can't use OpenCV cv.imshow function, which basically may have will display this image in your local machine. But on this cloud platforms, for some reason they have blocked the functions. After that, we'll pre-process the input image and then feed this to the model. So now we have read the image here. After that, we'll now just give the image to the model and do predictions on it. So you may have seen here in this code, we are saving the faces, whatever face we have got from this girl.jpg as face.jpg. So this was the original image, and this is the extracted face that we have got from the image. So you see the precision, guys. This is what the detector thinks is a face, but it's not sure till now that if it is a girl or not. So we'll just pass the face.jpg file into the model, do some predictions on it. This picture is of like, is this a girl or a boy? Let's see. So we already have our image. It's been read, and now let's do some predictions. So yeah, so we have predicted on this image, and let's check like what's the probability of if it's a female or a male. Okay, so there is some problem with this. I guess I've used the wrong model.
Yeah, instead of in that print section, instead of male, it should be female.
Okay.
By mistake, I had updated the notebook. I'm sorry. Yeah, please note that.
Okay, no problem. Yes, guys. So now for the validation, for the sake of validation, we'll change. We'll see for a different image also. So let's get here a man's image, and basically this image we'll use. As you can see, there is a man, a boy, and we'll pass the image into this, and we will save the image as face.jpg only in our directory. Yeah, so it has converted it successfully into array, and now we'll reshape it and pass it into our model. First, we will detect the faces. As you can see, it has detected the face successfully. Now we'll run the inference, run the model, and now as you have seen before, it has given the first image, the girl's image, as 75% female and 24% male. Now let's run the last cell and see the predictions. And yeah, so this image is 99.75% male and 0.25% female. Like the confidence of the model is pretty much great in this case. In this case of this image, let's try one more image that is of a girl, another girl. Let's try this image out. So we have got these images basically from Google. You can find them in Google search. If you search girl and just go into image section, and here we'll pass the girl to image, which we have seen here, and extract the faces from the girl. We'll visualize the face that we have extracted from the image, that is this one, and then we'll run our inference on it. And yeah, I guess it is now. Now concentrate on the output. Okay, I'm running the output, and it is saying that it's 99.52% female and 0.48% male. So the model is pretty much confident in this case as well. So yes, guys, this is how you can train a model, pre-process the data, whatever image data you have, and then deploy it using OpenCV on your local machines, or also on a system like an integrated system you may have in your house or in your campuses, where you want to detect if the person visiting you is a male or female, like if you're on the Tube stats. Yeah, that's the end, and thank you very much for following along till now. If you guys have any problem, any doubts, please put them in the chat section. And how did you feel about this tutorial? Please mention that as well. Yeah, I have now Sanya will take over. Thank you so much, guys.
Thank you so much, Aniket. I hope everyone is getting the result. And if you are facing any doubts anytime, you can message us. So I think you all are the part of Genesis Club members group. You can post your doubts there too. And I hope you found this session interactive and good. So anyone, do you have any doubts?
Hello guys, this is Saurabh Shah from Team Genesis. Hope you all enjoyed the workshop, and your support means a lot to us. So I'll be posting the Instagram link and the YouTube link. So subscribe us for more, follow us for more, tag us in your story if you like the workshop.
Yeah, so hi everyone. So I hope you guys enjoyed the workshop. Yeah, regarding the certificates, we'll shortly provide you a form in the members group, where basically we'll provide you the assignment of to get the certificate of this group. Yeah, is that right, Sanya?
Yes, you will just have to share your Google Colab link with us, and we'll provide you with the certificate. Thank you for
let you know about the certificates, like full process on the members group. So please don't leave the group since the workshop is done, and we will be posting more about like different workshops, projects, वगैरह on the members group. So like don't leave, you will miss out on a lot of stuff.
Yeah, exactly. So I hope everyone enjoyed the workshop. Yeah, I guess we can end the session now. Yeah, if you have any doubt,
thank you so much, guys.
at any time, you can just put it in the chat box right now, or you can put it on the members group if you have any doubt. All right. Yeah. So thank you, everyone. I hope you have a good rest of the day. Bye bye.
Thank you. Thank you.
Thank you, guys.
Thank you so much, guys. Thanks for joining.
Thank you.
We'll come up with such sessions time to time. Just keep watch on the members group.